Okay, so last day we learned a little bit about ionic compounds and some properties of them. Well, today we're going to learn how to write their chemical formulas, and I'm going to show you some tricks. This is typically one of the easier directions to go, writing the formula from the name versus writing the name from the formula. So I can explain this pretty easy. First things first. Ionic compounds are always written cation on the left and anion on the right. So typically, and I say typically, it is, ooh, hold on here. There we go. Sorry about that. Typically, it's metal and then non-metal. Now, this doesn't always need to be true, and there is an exception down below. This ammonium ion is a possible cation that is not a metal. Okay, so ammonium is called a polyatomic ion. And what that means is poly means more than one, atomic means atom, and then ion means ion. So a polyatomic ion is something, it's from your data booklet. I'll show you how to find them in a minute. And it's going to have an ionic charge, so like -1, -2, and more than one element. So I'll explain this kind of as I go through the steps. There's about 3 steps. Before I do that, let me just look at the chat here. So Bader mentions in the chat, we can use the table for this, and the answer is absolutely. You can use the periodic table and entire data booklet for the naming of any chemical compounds. I had a student in the other class ask me, when do you get to use the data book? And the answer is always. On a test, on an assignment, on a final exam, in the lab, you will always have the data booklet. Aman writes, when will I upload the last lesson? I should have my lessons uploaded by tomorrow onto the YouTube playlist. Okay, so back to this slide. Step number 1. Look at the name of the metal. So this would be the name on the left. Now, if there are Roman numerals in that name, that is your charge. So Roman numerals, you really only need to know the first 5. So 1 is 1, 2 is 2, 3 lines is 3. It gets a little different with 4, and then 5 is just a V. No idea why they picked Roman numerals. That's just the way it is. So if there are Roman numerals in the chemical name, that is the charge on your metal. If not, you have to look up the metal on the periodic table and write its charge. So I'm going to kind of show you the periodic table after the next slide. Well, I guess, yeah, after this slide. So something like zinc only has one charge listed. Zinc is always zinc 2+. We don't need Roman numerals there. Similarly, groups 1 and 2, they don't have any charges written for them because everything in group 1 is +1. Everything in group 2 is +2. So let me show you on the periodic table what I'm talking about. I might have it still open. No, I don't. Okay, I got to open it again. Hold on. It's not as hard as it looks once you practice it. Okay, so I'm scrolled down right to the bottom of the page. Here is my periodic table. So basically, everything you need to know about charges is typically written here. I don't know if you guys can see that. I'm up in the key in the top of the page. Common oxidation states, these are charges. They're technically called oxidation states. When you guys get to chemistry 2, or some of you who are going to do chemistry 2, we'll talk more about oxidation states in that. But basically, the idea is our charges are written on the top right of the periodic table box, or the element that the box is in. So you'll notice there's nothing in group 1 because the charges on group 1, I forgot that my pen did this. The charges in group 1 is +1. The charge in group 2 is +2 or 2 plus. Then with the rest of the metals, you typically need to figure out the number. So aluminum, zinc, and silver, their charges, for example, are just listed. We have silver with a 1, zinc with a +2, silver, aluminum with a +3, sorry. Okay, now some of the metals in the periodic table will require Roman numerals in the name, and that would be like iron, cobalt, nickel. What this number means is that iron can be iron 3 plus or iron 2 plus. The 3 comes before the 2 because the 3 is more common. The order of the numbers don't mean anything outside of that. So any of these metals that have more than one charge, like iron, cobalt, nickel, copper, zinc, these will have, not zinc actually, sorry, ending at copper. These will need to have Roman numerals in the name. And the reason is the difference between iron 3 chloride and iron 2 chloride, for example, they're completely different chemicals. So you need to know in the name which you're dealing with. So let me go back to my slides. Okay, so step 1, look up the metal name. Again, if there are no Roman numerals, then you look at the periodic table. So this isn't really like a practice problem. This is just to get us kind of ready for the real problem of today. All I have to do is name or write the names of these cations with the charge. So it shouldn't say name, I guess. It should just say write the cation. So iron 2, that's Fe2 plus. Now remember your Roman numerals. So 1 is 1, 2 lines, sorry, that was a bit close. It's 2, 3 lines is 3, IV is 4, and V is 5. We won't really go anywhere bigger than 5. Okay, tin 4 chloride, well, tin is SN, and 4 would look like this. Now, sodium, I know, is in group 1A, so sodium's pretty easy. It would just be sodium plus. We don't need the number for sodium, but germanium, I don't know. So now I know it now because I just did this in the other class, but before I did it, I couldn't remember what germanium is. I don't have all of these numbers memorized. So I go back to my periodic table. I find germanium. It might take you a minute to find it, Ge. And I notice that it has a number 4 in the top right corner. So that means the charge on germanium is 4 plus. So there you go. That's the first step in writing a chemical formula. Warda asked the question in the chat, how do we know if it's positive or negative? Metals are positive, non-metals are negative. So the way your name will work is that the word on the left is positive and the word on the right is always negative. So metals are always positive, non-metals are always negative. We write the name so that it's cation, then anion. No problem. Okay. We're going to put all this together in a minute. Step number 2, I think there's a step 2 and a 3. Step number 2, look up the name of the anion, that's the second word, on your polyatomic ions table. If it's there, you're done. You write the ion and its charge, and you're kind of ready to finish. If it's not on your polyatomic ion table, it will be on your periodic table. And I'll show you how to get the charge from the periodic table. Now, one thing to mention, I'll just give you a hint. If the name ends in 8 or ite, it's probably polyatomic. So if you look at the examples on the left here, phosphate and nitrate, those are definitely polyatomic ions, whereas oxide is not. So let's just look at these examples. Let's see if we can find the anions formula. So first things first, I go to my periodic table. I'm going to scroll up to the very top. This, by the way, guys, I've had outside my office for weeks now. So if you still haven't picked up a copy of your data booklet, it's outside my office. But anyways, we're looking for phosphate, which is right here, PO43 minus. And since I'm here, it's also asking me to look for nitrate, NO3 minus. So phosphate is PO43 minus. Whoops. So phosphate would be PO43 minus. Nitrate would be NO3 minus up top. And then sodium oxide would just be O2 minus. Now, why? Like, why is that different? Well, if I go back to my data booklet, I've got a lot of clicking around today, I'm sorry. You'll notice that nowhere on this slide is the word oxide. There is peroxide, but that's not the same thing. So nowhere on this polyatomic ion list is oxide. Again, there is peroxide, but that's not the same thing. So that means if it's not here, oxide must refer to the chemical oxygen on my data booklet. And just a little hint for numbering the anions. Okay, so basically we're only going to have to worry about 3 of these groups. Any halogen has no charge, not going to be involved in bonding. All of the halogens are 1 minus. All of these groups, the chalcogens, are 2 minus. And all of the next group, the pnictogens, which you don't need to know the names, are 3 minus. So I know that oxide is 2 minus. The reason there's 0, -1, -2, and -3 has to do with their electron dot diagrams. So fluorine can take 1 electron, so it becomes -1. Oxygen can take 2 electrons, so it becomes -2. And nickel can take 3 electrons, so it becomes -3. All right, we're going to put this all together. I only have 2 slides left. I'll show you how to put this all together, and then we'll do a couple of examples. Okay, so step 1, write the metal ion. Step 2, write the non-metal ion. And step 3 is to keep adding anions and cations, positive and negative charges, until the positive equals the negative. They must cancel. So if I had to write the chemical formula for Mn4+, manganese 4+, and carbonate, well, I know I have 2 minus, and I know I have 4+. So if I add another carbonate, now I have 4 minus and I have 4+. So they're equal. The formula for this compound is MnCO3, and then we put that CO3 in brackets and 2. All right, let me just check the chat here. Yep, I can go back to where which slide? Somebody in the chat just asked me to go back.
Sir, can you do the steps 3 again, please?
Yep.
After.
Yep, after, not a problem. And Iman has a question about oxide. So yeah, let me know your question. Okay, I just went a little too quick. Okay, cool. All right, so somebody also just asked me to look up step, or kind of talk about step three. So step three, you have to make sure that the charge on all of the cations cancels the charge on all of the anions. So again, imagine if I gave you the example Mn, so manganese 4 carbonate. The name of this compound would be manganese 4 carbonate. Sorry about the pen there. And the charges are not balanced. I have a +4 and a -2. If you add them up, it will not equal 0. So what I do is I decide that this ionic compound needs another carbonate, and then you can add up the total charges. I have 4 negative and I have 4 positive. They cancel. You can do that on your calculator if you don't believe me. +4 plus a -4, they get 0. So this is neutral. This is
Yeah,
how
sir, but why you put a twice of the CO3?
I put 2 of them there so that their charge would equal -4. Does that make sense?
Ah, okay.
And the -4 needs to cancel the +4. Okay, so one little note, and then I'm going to show you a bunch of examples. One note here, you cannot use half elements to get this to work. So like in this slide back here, you might say, well, why don't I just divide the manganese by 2, and that way the charge will be 4. You can't divide elements, not by chemical means. They don't get any smaller. So you have to use whole numbers. You can't use decimals when you're doing this. And I mean, that's good anyways, because we don't really want to be using decimals. They're not the easiest to work with. Okay, so guys, let me show you 4 of these. And here's my plan for today. I'm going to show you these 4. And then that'll be it for today's class. I'll then ask you guys to try these. And it might be easier for you to try them when I'm not talking. You can use your data booklet. The data booklet is on D2L. So if you don't have a copy, it is on D2L. So I want to do these 4. I'm going to let you guys try these overnight, and then tomorrow we'll look at the answers. So here we go. Step number 1. For each one of these, I need to write the cation. Well, sodium is pretty easy. Sodium is Na. Calcium is Ca. Nickel is Ni. Ammonium, though, I haven't really seen that before. Ammonium, that's not an element. There's no element called ammonium. So whenever I see a word like this, or specifically a word that ends in ATE or ITE, I want to check my polyatomic ion chart. Now, I'm not done with the metals. I obviously need to write the charges, but I'm curious about ammonium. So I'm just going to go up to my polyatomic ion chart, and sure enough, I see ammonium. Ammonium is one of the only ones that has a positive charge. So ammonium is right there. It is also asking me to look up the names of phosphate and nitrate. So since I'm here, I have the chemical formula for ammonium, phosphate, and nitrate. So I hope you guys can see that. So I'm just going to go back to my notes and copy those down. So I haven't really done much thinking yet. So phosphate was PO43 minus. Nitrate, well, ammonium was NH4 positive, and nitrate was, I should move these over.
So teacher, you need to check the table and matching together, yeah? And you need to minus and add.
Yes.
Okay.
Okay. Sorry, I'm just making a list here. Okay. Now I'm still not done. I still have to do a couple things. I need to get the charges on my metals, and I also need to write the other ions, the anions, sorry. So, okay, sodium. Sodium is in group 1. So the charge on sodium is +1. Calcium is in group 2. So calcium would be 2+. And nickel, I already have my Roman numeral right here. It's given to me. So there we go.
Mr.
Yes.
The screen is not moving.
Sorry?
I think it's the screen is not moving. I think it's frozen.
Oh, there we go.
Yeah,
All right.
yeah, now it's.
All right, so
So
let me.
could you repeat, please?
Yes, let me write that again. All right. Okay. So sodium is in group 1. So I will put a +1 here. Calcium is in group 2. So I put a 2+ there. These are just things that you have to memorize about the periodic table. And luckily, I don't have to memorize anything here. Because it says nickel 2, I know the charge on nickel is 2+. If it was nickel 3 or nickel 4, I would change my number accordingly. All right, I'm almost done writing the cations and anions. Now I just need to write my simple anions. I have oxide and sulfide. Now, oxide and sulfide are right above each other on the periodic table. Let me just go look at that. Okay, so oxide and sulfide are right here. Okay, we have O2- and S2-. All right, so O2- and S2-. Okay, we're ready. Some of these look really easy. 2 of them are especially easy, and then one of them looks a little harder.
From where we got these ions?
From the periodic table.
The NO3- and S2-, that's all from the table?
Yep, from my data booklet. So the PO4 3- and the NO3-.
So that's mean at quiz we will have this data book?
Yes, you will have this data book, and you can see where I get my information here on the screen I'm sharing. There's nitrate, there's phosphate, there's ammonium. They're all circled. You don't have to worry about peroxide. And you will have this data booklet on your test or final. It's in your lab in front of you. I mean, you'll always have this. Okay, so putting it all together. Now I need to come up with the chemical formula. And I'll pick a different color. Okay, so I have Na+ and O2-. I am going to need 2 positives to cancel out my 2 negatives. So my formula here would be Na2O. 2 positives and 2 negatives, add them together, that's 0. So my compound here would be Na2 subscript 2 O. Now these 2 guys are extremely easy. I have a +1 and a -1, and I have a +2 and a -2. They're already canceling. I have +1 -1, +2 -2. So I can just put these together without doing anything. And CAS. This one on the bottom ends up being a little tricky. And let me just check my chat here. All right, I got a question about finding the data book on D2L. I will show you that. I am recording for sure, and you should be able to see my screen. Can you guys see my screen, the answers?
Yeah, it's okay now.
Okay, maybe it might just be the internet being a bit lagging or something. Okay, now guys, I want you to focus special attention on this last one. I'm going to show you a trick that will help you, but what I want you to do is just come along with me to a blank slide, and we'll talk about nickel 2 phosphate and how I get the name for that. Okay, so here we go. Nickel 2 phosphate. All right, so this is probably one of the harder ones. So let's break it down. Nickel 2 means that my cation is nickel with a 2 positive. Phosphate, this is in my data book. You don't need to memorize this. Phosphate is PO4 3 minus. This is a polyatomic ion. Now, there's two ways to do this. I'm going to show you the easy way. Well, no, I'll show you the logical way, and then I'll show you an easy way, like a little trick you can do. Okay, so the logical way. I need somehow for these positives and negatives to cancel. So what I'm going to do is I'm going to keep adding ions until I can get the positive and negative equal. So I have 2 positive and 3 minus. So let's add another nickel to this equation to see what happens. All right, now I'm looking at 4 positive to balance with 3 negative. So that obviously doesn't work. So I'll add another phosphate. Sorry about that. Okay, hold up. So let's think about this. On the left side, I have a total of a 6 negative or negative 6.
So add one more NI negative.
Yeah, exactly.
To be safe.
Exactly.
Yeah.
So now what I do is I add one more Ni, and now if I add up all their charges, I get 6 positive. Perfect. It cancels. Everything's happy. So the way I write this formula is I would say Ni, oh, this pen, Ni 3, because there's 3 of them. And then I would write PO4 2. But look at how weird that looks. Ni3 PO42. It almost looks like I have 42 oxygens. So what I do is I just put brackets around the PO4 so that the 2 means I have 2 phosphate ions. Okay, so I told you I was going to show you the logical way, and now let me show you the trick, the shortcut. Okay, let me show you this again. So Ni2 plus PO4 3 minus. One thing you can do, and you do have to be a little careful here, but it works 99% of the time, is I can bring this 2 over here and this 3 over here. I've heard this called the crisscross method. So the 2 from the nickel goes on the bottom of the phosphate, and the 3 on the phosphate goes on the bottom of the nickel. So I've heard of this, I've seen this used before, called the crisscross method. So you can kind of use whatever one you want. This is a little shortcut. Let me just check the chat here. Kevin actually brings up something also really important. I mean, arguably, there's a third way to do this where you could find the lowest common multiple of 2 and 3 and then figure out how to turn them into that. I mean, that's basically what I did over here on the left. Okay, so guys, what I'm going to do, this is a lot to take in. I'm going to give you a break for today. We'll stop at 3:05. I will show you where to access the data booklet. But what I would like for you guys to do tonight, and it's not really homework. I mean, you don't have to do it, but I would like for you to try these. You might get them wrong. You might get them right, but the point is to try them. And tomorrow we'll take our time and we'll look at the answers. And then after tomorrow, well, sorry, not after tomorrow, but after that, we're going to learn at writing the name from the formulas, which can be a little tricky. Okay, so I'm going to stop there. I'll hit stop record. And